So good evening, everyone. My name is Ravi Subramaniam. I'm here to deliver an invited talk on understanding the importance of standardization and conformity assessment. So it was pretty interesting to hear about the previous panel, and probably this is a good segue. Thanks again for staying for this. I represent the IEEE, the Institute for Electrical and Electronics Engineers. We are probably one of the largest membership-based organization that has about 500,000 members worldwide, spanning across 160 plus countries. We house about 46 different technical societies and councils that look at various technology areas. We also do host over 2,000 annual conferences across the globe, and we're also involved in multiple global and humanitarian efforts. IEEE Standards Association is a business unit of the IEEE that specifically focuses on developing market-relevant and open standards. The key focus here is to advance global technologies and platforms, as well as promoting innovation. So really gathering industry experts in promoting public safety, health and well-being, as well as contributing to a sustainable future. Just a quick look at IEEE Standards Association. At any given point in time, we have multiple standards projects under development. We have more than 1,800 standards. We have over 400 corporate members or companies that are participating in standards development. We also have about more than 8,000 individuals and experts who contribute to standards development, spanning over 30,000 global participants. And we also manage agreements with multiple regulatory agencies, other standards developing organizations. And just to kind of give you a broad view of some of the technology areas that we are involved in, anywhere from nuclear, up through Wi-Fi, sustainable energy, nanotechnology, including sensors and IoT. This is just a small subset of some of the particular technology areas that we are developing standards as well as products and services on. So what is the impact of standards? If we look at Wi-Fi, Wi-Fi is actually an IEEE standard. It's IEEE 802 standard, if most of you are unaware. Wi-Fi was actually brought into IEEE for a particular use case way back when they really wanted cash registers in a departmental store scenario to be able to communicate with one another. That was kind of the first use case. And of course, as we all know it, Wi-Fi is used for in multiple scenarios now, anywhere from connecting your phone to the internet while you're here at the hotel, up through use of medical devices for monitoring medical conditions, administration of drugs, and so on. So Wi-Fi is a pretty large market, and it kind of helped to proliferate because of the existence of standards. We are now currently looking at about 18 billion Wi-Fi devices shipped, 8 billion still in use, 3 billion new ones being added every single year, compared to just 1.6 billion smartphone devices annually shipped. So you can kind of see how standards helps to evolve different technologies. So how does the standards development process actually evolve at IEEE? It all kind of starts off as an idea. So standards are developed by not a room full of IEEE employees or folks that are invited. It's really the constituents, the volunteers, the members. They come together with an idea. It may initially start off as a workshop. It may start off as a webinar. It may start off as an academic conference. But eventually it evolves into some sort of publication or a research or study group. And that group may eventually have enough content or see a strong brewing support to develop actual standards documents. So it's a collective effort of competitors, collaborators, even policymakers and regulators coming together to create standards. And eventually those standards are deployed. And this is kind of a quick snapshot on how IEEE fosters these. The previous slide, which showed all the activities. The Industry Connections Program is sort of seen as an incubation group where ideas are put together. Some initial stakeholder input is collected and driven up until leading to the actual standardization process. So this is where standards working groups evolve, they come together, and actual development of the standards occurs. We also have membership where we bring in expert resources, corporate companies, as well as users, end users of the technology to help proliferate those activities as well. Conformity assessment is another piece that I will do a little bit of deep dive into. Conformity assessment is where we would evaluate that products actually meet requirements established in a standard. And then we also have registries. We also help to foster the technology being adopted through, whether it's through the formation of a consortia or an alliance, also as well as hosting open source platforms. So standardization outcomes, we talked a little bit about this. It helps create competition in the marketplace. It also enhances innovation. It helps improve and fine-tune performance, improving efficiency, thereby bringing about confidence in that piece of technology and also facilitating growth, while at the same time, which is now of very strong interest, is ensuring not just sustainability in the form of environmental sustainability, but also financial sustainability. These are some of the key focus areas that IEEE focuses on. Health and life sciences. I think coming out of the pandemic, we realize this is an important space that we have to keep a watch on. Mobility, which is another big topic, autonomous driving and so on, that is kind of focused in the mobility practice. Energy, which is sustenance that we need, smart energy, energy efficiency, energy infrastructure, including distributed energy resources, renewable sources, and things as such. Telecommunications is another area where we are actually trying to bring connectivity into rural areas as well, and also managing wired and hybrid communication technologies. And then we have two other new areas where we are looking at foundational technologies, so really looking at emerging areas like industrial IoT, consumer electronics, which is also evolving, and then also looking at new frontiers, which is your sustainability, and of course, autonomous intelligent systems, which is, again, another area of significant growth in the last few years. So standards are developed at IEEE utilizing two particular methods. One is an individual method, and the second one is an entity-based method. So individual method is basically in a room where we have a standards working group where you represent yourself within the work group, and you have one vote towards the approval of the standard. So in this particular scenario, individuals represent themselves. They have one vote. They participate in the balloting process. In order for the standards to pass, we need a minimum of 10 individuals. In most cases, working groups have significantly much more than 10 individuals participating. The only requirement for participating in such a ballot is that you have to be an IEEE SA individual member. To participate in the work group in itself, you do not actually have to be an IEEE member. So really going with the theme that it's open membership, open participation, there's absolutely no restrictions. Any individual or organization can participate, including academic institutions and users as such, and any industry, any size of company, be it a large Fortune 500 company or a small startup. And then the entity-based method is really one company, one vote. So it's a very similar kind of scenario, but now in this particular scenario, you would be representing your company. And in this case, you need a minimum of 3 corporate member companies to participate. And usually you would see that companies are sponsoring the employees to attend these meetings and travel to do so. We developed 4 different kinds of documents. We collectively call them standards, but they really could be any one of these. One is a standard, one is a recommended practice, one is a guide, and then trial use document. So a quick way to say, define them is standards usually use shall statements. You shall meet these different requirements. Recommended practice would utilize statements like you should. And then guides are more may statements, or you can use these types of methodology, etc. And trial use documents are a little bit rare. It is usually considered for trial use status. So it might be you don't really have a consolidated method. You don't have full, well, we try to drive for consensus with any of these documents, but it might be somewhat of an immature technology, so you would issue a trial use document. So I'll kind of move into conformity assessment. What is conformity assessment? Conformity assessment, again, is the process by which a user or manufacturer could demonstrate that they actually meet requirements set forth in a standard. So for example, if you have a sensor and you say the sensor is able to do ABC, how do you demonstrate that to your potential buyer? How do you demonstrate that your product actually meets requirements required by not just the buyer, maybe in regulation or by law? So there's multiple benefits to having a conformity assessment program. In fact, if you look at any well-established technology, there's usually some form of conformity assessment associated with it. So it really provides manufacturers a proven method of demonstrating conformance. From an end user standpoint, some end users may not have the technical depth to analyze a product that they might be purchasing. So they heavily rely on certifications. So if a product that has been certified may have a logo, and people are drawn to that. If they see that this product has a particular logo, they feel that it has gone through some process to achieve that logo, and then they feel comfortable buying it. And certification programs end up being sort of a shared resource. It really benefits the supplier to gain market acceptance because it's based on an international standard. Imagine trying to sell your product globally in different regions and parts of the world where there might be deviations or there might be special requirements. Having conformance based on an international standard that's adopted globally helps to reduce that burden. Okay. So what is conformity assessment? So in your mind, you might be thinking, yeah, I have a product. I'm going to send this to an independent lab, or I'm performing some testing on it on my own. That is one form of conformity assessment, testing and evaluation. But conformity assessment can also manifest in other ways, which could be a commissioning activity, where you would go to an actual installation and actually do a commissioning of that particular installation. It could also be an interoperability event, where you are trying to bring equipment manufactured by many different manufacturers to ensure that they all interoperate. That is also a means of exercising conformity assessment. It could also be an inspection activity or an accreditation process. Test suite development. So test methodology or test plan development is a significant part of conformity assessment activities as well. So at IEEE, when we use conformity assessment as a term, we kind of collectively think of all these different things. Again, so who decides what type of conformity assessment should be used? This is really driven by industry. It's not a particular organization decides that, oh, we're going to do an interoperability event. It's really a collection of what the industry needs and how we're going to drive it. So we covered a lot about this. So why is conformity assessment important? And I really like this slide because it talks to back in the early 2010s, or right before 2010, we went through a financial downturn. The world economies were all affected by this. And at that time, the US government actually had an American Recovery and Reinvestment Act that really kind of helped to spur investment into the US power grid in order to modernize that grid, where we had a lot of legacy products and systems that were decades old that had to be replenished to keep up. So a significant amount of investment went into the renewal, where they introduced this technology called synchrophaser. Synchrophaser is a product that goes on the power grid that is able to monitor frequency and voltage fluctuations and introduce appropriate warnings and measures to eliminate any kind of outage that could happen. So very, very great technology. This was eventually standardized at IEEE. And they actually tested, they pulled out 10 out of 10 PMUs of synchrophasers from the marketplace and tested them. 8 out of 10 of those synchrophasers actually did not meet requirements in the standard. So this is a significant discovery, and it could become a big issue, especially when you have stranded assets like the power grid, where you are reliant on power to conduct business, and GDPs can be affected if things don't go as planned. So this kind of really pushes the point that you trust products and technology, but you also have to verify. So conformity assessment could be could manifest in different ways. Again, first party, second party, third party. First party conformity assessment is where a manufacturer self-evaluates and self-declares that they conform to the standard. Second party is where the conformity assessment is actually performed by often the end purchaser of the equipment. Third party is where a completely independent organization makes that assessment that does not have any financial interest in the business or the product. So what kind of conformity assessment really should one adopt? There's actually no right or wrong answer to this. It's really up to the industry to decide. For example, second party conformity assessment is actually strongly used by, for example, the Food and Drug Administration. They do a lot of conformity assessment around that. Even the aerospace industry, for example, Boeing and Airbus, where they source a lot of products that goes onto their aircraft, they actually perform their own conformity assessment, so second party. And then third party's conformity assessment. In Europe, consumer electronics that utilize the CE mark, they use first party. But in the US and in the North American region, they actually use a third party conformity assessment where it has to be certified by an independent body. So these are some of the pillars we need to have a successful certification program: a demand driver, a standard, test specification. You need test labs and tools. You need vendors who are actually implementing the requirements of the standards within their product. And then last but not least, outreach and education. You need to advise the industry stakeholders of why this program is there for their benefit. The demand driver, I want to just very quickly focus on that. So any kind of certification program would really not be adopted unless there's a very strong demand driver. Demand drivers are usually in the form of a legal driver, a legal mandate, or it's in the form of a market mandate. So a legal mandate is you're required by law to meet specific standards, or you have to go get your product certified in order to do business in that particular region. Or it could be a market mandate. For example, I would not go buy a cellular device or a wearable device that has no Wi-Fi capability. So I, as an end user, the market, I demand that it has to have Wi-Fi capability. So that demand driver needs to be clearly identified. If not, certification programs would not survive. So I'm going to, in the interest of time, I'm just going to quickly talk about two different programs that IEEE has. One is the Nuclear Standard Certification Program, where we are looking to build, where we used the IEEE standards to develop a certification so that products going into a nuclear power plant actually conform to the standard. So there is a testing and certification regime that we encourage products have to go through. Again, this is a voluntary standard, meaning you're not required by law, but a lot of manufacturers and test labs participate in this program in order to differentiate themselves. We also host a software as a service platform to help you go through the entire process, because by regulation, a utility that owns and operates a nuclear power plant is required to maintain an EQ, or equipment qualification binder, for the life of the plant. And this process helps to simplify and reduce costs in doing so. These are some of the stakeholders in the process, and as you can see, it's not just the manufacturers, it's not just the utility, it affects a lot of other people, including insurance companies as well. The other quick thing that I thought would be of interest to this group with the CTBTO, with measurement and utilization of sensors, wireless technology and IoT is really kind of helping to proliferate use of sensors in smart city scenarios, mobile health, connected retail, industrial applications, etc. With that, there is this control loop that we run into where we have sensing operations, data collection, and then analytics that happens, and then some form of decisions are being made, and then you actuate, and then it's a closed loop operation. So with this particular scenario, where you have technical requirements, but now we are also pivoting into non-functional requirements like trust, identity, privacy, protection, security, and safety. So IEEE is actually developed standards around this, providing some guidance. And then we are also in the process of forming a committee, or actually a committee has been formed, that is really looking at utilization of sensors, addressing significant issues like interoperability and cybersecurity. These products now, as they are used in critical infrastructure, they are prone to cyber attacks. They could run into interoperability issues. Data architectures are different, so data could be interpreted in a wrong way. So these are some of the problem areas that the committee is trying to fix, and I would highly encourage those that are interested to participate in this activity as well. So with that, I've come to the end of my presentation. If we have time, I'll take a question or two. That's okay.
Thank you very much, Ravi Subramaniam from the IEEE. Now the floor is open for questions. Yeah, Thierry, please.
Thank you very much for your presentation. It was very interesting, and I feel in particularly the conformity assessment you mentioned, because in the case of the verification of this treaty, the system is supposed to detect nuclear explosions. No standards for that. It's unique. There is nothing. However, each and every piece, you heard the metrology before for the sensors, and very often the engineering starts are applied for the pieces, but at the end, there is a commissioning plan, but there is the conformity assessment, and there is no foundation for that except an evaluation program that review with the clients, the state signatory, how this is progressing toward this end. And I was wondering if all your practices or standards could somehow help to solve this problem that do not have a solution, actually.
Absolutely. So thanks for that question. I think that is the intent or the platform that IEEE provides. Bringing together the stakeholders so that we can have collective discussion, develop solutions, and then deploy those solutions. So we are definitely keen on providing that platform. Again, we can help initiate the process, but the process is actually driven by industry stakeholders. So you yourself and your partners, your collaborators can come together and work on these solutions, and IEEE provides that platform. I think there was one question over there.
Thank you. Yeah. Please.
Thank you. Yeah, for my experience of standardization, I can define it as a source of traceability. So if you have your standard of conformity in Europe, for example, and you need to supply a product to Russia, to China, that's a complete different stories. How do you balance this if you have to supply to Russia and China, and you have your own set of conformity? How do you interoperate together?
Yeah, so standard is not a full solution, right? But it could be part of a solution. So we have seen that there will be regional differences. Even if you look at US or European countries, there could be deviations from different state to state. So standards could implement some of that. But it's really to kind of reduce the burden, to come up with at least a baseline that everyone can follow. But we recognize that different regions may have different requirements that would still have to be addressed.
Thank you. Any more questions from the floor? Yes, I see one, please. I will also have a question, and we can go a little bit over time because there's nothing else scheduled at the same time right now. Please.
Good evening. Thank you so much for your talk. I had a question regarding basically conformity assessment and how it's regional variations. Do you think that because it's a voluntary action, it could be used in the near future to do something like confidence building or increase regional cooperation, or that would be like a lot more into the future rather than something that can be taken as a short term?
I'm still trying to understand what your question is. So are you saying because of regional differences, the conformity assessment may not work?
No, my question is, do you think that conformity assessment can be an instrument in regional cooperation and confidence building?
Oh, absolutely, absolutely. So when we put a standard out, I'll give you a very firm example. We have an IEEE standard called 1547. This is a standard for interconnection of renewable energy sources. So if you have solar up on your residential home, on your roof, you want to interconnect with the power grid, this particular standard gives you requirements how to safely do so. This standard was originally developed for the US power grid, but now different regions are starting to adopt this particular standard. And if you are familiar with electricity, there are some countries that operate on a 50 hertz system, some countries that operate on a 60 hertz system. So there's obviously some nuance there, and the standards won't very easily apply to a 60 hertz system, for example. So it really kind of helps to bring all the stakeholders and say, hey, this standard is so good, we want to use this on our 60 hertz system. we're going to contribute to the standard so that it can also be used on the 60 hertz system. So it really kind of helps bring countries together to collaborate to improve the standard. And then once the standard is improved, you might say we're going to also certify to the different versions or different requirements of the standard. So yeah, so it really helps collaboration. It also helps streamline where you test once and you're able to market globally. So better market acceptance. Great question.
Thank you so much.
Thank you very much. Any more questions from the floor? I don't see any. I would like to also comment a bit and raise a question, open-ended maybe. So the CTBTO organization, of course, we apply our own standardization and conformity assessment methods. They were developed with the experts of the member states. We have them in place since many years. For example, we have our stations. We have requirements for the stations. They are defined and agreed. And we need to check every new system whether it meets the requirement. And we call this a certification process according to a certification document with all the requirements listed and procedures. Recently, we invented a systems acceptance procedure for a new generation of noble gas systems. All the experts internationally agreed on how we do this process and what are the criteria. Of course, they are linked to the certification criteria. When it comes to standardization, we, of course, have not only technology and sensors standardized, but also software and data, for example, data format. It's not that the CTBTO did this, but we are using the standardized formats. For example, for the seismic data, there's the SEED format and the mini-SEED derivation. And this is not the format that we are using. We are using our own, we call it IMS format, International Monitoring System format. And there are scripts to transfer one format into the other. There are various software approaches for seismic data, and they all have their own format, and they need to be transmitted or transferred to each other. Same with radionuclide data. We have our own radionuclide data format, which is not compatible with commercial software formats. So there's a lot of further need for conformity, for interoperability. Also, I think it's helpful if we get some professional review of our procedures and certification methods and assistance or advice from a party like you. You have a vast experience in these topics. So my open question is, how can we join forces? How can we find out what are possible needs or opportunities where we can benefit from your deep knowledge and experience? And I say it's an open-ended question because the purpose of inviting you here to this conference and give this presentation is to make the audience aware of what IEEE can offer. We also have in the next panel in this room at 6:30, we have again a representative of IEEE, Massimo Pellegrino, and he will represent the organization as a whole, not just standardization. So it's an open question that we want to start here today, but maybe you have some initial answer to this question as a wrap-up of your presentation.
Yeah. So I'm a firm believer of starting small, show some success. There are multiple avenues I see. CTBTO obviously has some processes that's already in place. It might be a very good process.
Yes.
And it's unfair that you keep it just within CTBTO. If it's so good, maybe there's an opportunity for IEEE and its constituents to benefit from that as well. So really kind of giving that, having that opportunity to exchange and share those ideas is one point I'd really like to make. Training and educational scenarios, I think, is critical in this aspect. So, whether it's webinars, it's workshops that we do together jointly, where we bring IEEE experts as well as CTBTO experts to share and exchange that information. The third big piece is this. These sensor manufacturers that CTBTO and the IMS are using, that's not their sole area of business. They are making sensors for autonomous vehicles, they are making sensors for aerospace. If we can find synergies to consolidate some of these, is really going to help the industry, I think, as a whole. So that's my initial thought process, and we are very receptive to having those extended discussions and see where it takes us.
Wonderful. Thank you very much, Ravi Subramaniam from
Thank you.
IEEE, and thank you for attending this event.